Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Hey everyone, and welcome to this explainer. Listen, today we are going to fundamentally shift your mindset. We're moving away from treating AI as this magical, unpredictable black box, and we're going to start treating it like a rigorous engineering contract. Seriously, if you've ever built a chat interface that felt super fragile or lost its context, or just suddenly broke because a user clicked a little too fast, you are absolutely in the right place. We're going to look at exactly what separates a Hacky weekend demo from a truly bulletproof production-ready AI integration. To do this, we're dissecting a robust AI integration by looking at 5 distinct organs of the system architecture. 1. The contract. 2. The character. 3. The weight of memory. 4. The defenses. And 5. The safe return. Let's get right into it. All right, let's establish our paradigm shift right off the bat. A basic, rigid chat system, it just blindly passes text back and forth. It's really just a dumb pipe. But a true contextual AI processes highly structured inputs. It actually understands the roles of who is speaking, it holds on to the context of the history, and it perfectly respects specific behavioral parameters to create this beautifully smooth, coherent flow. The real magic happens when you realize you aren't just asking for text, you're managing a highly structured exchange.
Okay, Section 1, the contract. Let's talk about defining the payload. Modern AI APIs do not guess your intent. They actually expect an object with a very strict defined shape. Every single field here has a precise purpose in a strict location. You've got the model, which selects your specific engine as a string. You've got the system field, dictating the top-level rules and the core identity of the AI. Then there's the messages array, handling the turn-by-turn history. And finally, your generation parameters that dial in things like creativity and length. Every piece has to sit exactly where it belongs.
Now here's a massive pitfall developers fall into all the time. The fragile approach of nesting the system prompt directly inside the messages array as a special role. I know this is a common habit from using other providers, but if you do this in Anthropic's contract, it instantly triggers a bad request error. Bam, done. The robust, correct way is keeping system as a top-level field, totally separate from the turn-by-turn message history. Nest it wrong, and the API either ignores your rules completely or just outright rejects the request.
Moving right along to Section 2, the character. It's time to design the AI's DNA. Think of a heavily profiled prompt as your character's literal DNA. Take a look at the weak prompt. You are Marie Curie. Answer questions. Honestly, that leaves way too much open to interpretation. But the profiled prompt, it explicitly says, act as Marie Curie. Answer clearly, max 3 lines. Suggest a simple experiment if you don't know. By doing this, you significantly reduce personality drift. You're setting explicit, unbreakable constraints on tone, length, and exactly how the AI should behave when it faces uncertainty.
And to lock this behavior in even further, we tune our generation parameters. Think of temperature as a risk dial. Keep it low for super deterministic, consistent answers, or crank it up if you want the model to take some creative swings. Meanwhile, max tokens? That's your strict budget cap. It is the ultimate safeguard against the AI just rambling on and burning through your wallet. But wait, here is a super critical detail that gets overlooked way too often: the stop reason field. When the AI finishes returning text, it literally tells you why it stopped. You have to check this. Because if you set your max tokens a bit too low, the AI stops mid-sentence, and it returns a stop reason of max tokens instead of a natural end turn. If you aren't checking for that, your UI is just going to show a broken, half-finished thought. You've got to catch that and warn your user about the truncation. Which brings us nicely to Section 3, the weight of memory. Let's talk history and tokens.
You really have to understand that tokens are your literal, actual budget. A token is roughly a chunk of text, somewhere between a word and a syllable. And here's the kicker. The API has 0 memory of its own. None. It counts every single token you send it and every single token it generates back. Every API call is treated as a completely blank slate unless you actively send the history along with it. Just look at the pain of unmanaged memory right here. Sending a single message costs you, say, 35 tokens. But just adding 4 previous turns of conversation history, it triples your input tokens to 112. Because you're resending the entire context every single time, this compounding weight directly spikes your API costs and absolutely crushes your response times.
So to prevent burning through your credits, you've got to treat memory like a strict budget. The best practice is trimming that history rate down to just the last 8 to 12 relevant turns before every single API call. Use pure, non-mutating functions to append your messages, carefully monitor token consumption in your logs, and honestly, the biggest one, completely reset the history array whenever the user switches contacts, or the AI is absolutely going to start mixing up personalities.
Okay, Section 4, the defenses. How do we shield against rate limits?
Let's be real, the magic of AI vanishes instantly when an impatient user double-clicks the send button and your entire UI crashes with a glaring 429 too many requests error. APIs strictly enforce these limits to protect their infrastructure, capping both your requests and your tokens per minute, and when you hit that ceiling, everything shuts down.
That's exactly why you need these 3 specific layers of defense, applied in sequence. First, debouncing. Wait a tiny 150 to 300 milliseconds to cancel out spam clicks before a request even leaves the browser. Second, a UI lock. The exact moment a request fires, you set an is-loading state that disables the send button. It acts like a bouncer at the door. And third, if a 429 error actually still happens, you do a procedural read of the retry after header, show the user a clear countdown, and execute exactly 1 automated retry.
If you map these frustrating symptoms directly to these defensive strategies, you essentially guarantee that external limits will never break your user's flow. User spamming clicks? Debounce stops them. Duplicate requests firing? UI lock prevents it. And if they hit a rate limit, giving them clear visual feedback like waiting to refresh keeps them from rage refreshing the page.
And finally, Section 5, the safe return, parsing those responses.
Here's an assumption that breaks so many front ends. If you take the fragile approach and assume the API's response is always going to be just a simple text string, you're setting a massive trap for yourself. Modern APIs return an array of blocks under the content field. If the API suddenly returns something unexpected, like a tool use execution block, and your parser tries to read it as raw text, your front end is going to completely shatter.
Instead, you've got to use this robust parsing logic, extract the content as an array of blocks, systematically filter out absolutely everything except where the type explicitly equals text, map those text blocks into strings, and safely join them together. This brilliant little flow guarantees your UI only ever tries to render text, gracefully ignoring complex tool blocks without throwing nasty type errors.
So after exploring these 5 crucial organs together, from defining the rigid Anthropic contract to profiling the character's DNA, managing the brutal weight of history, building defenses against rate limits, and safely parsing those array blocks, I'm going to leave you with this final thought. Are you engineering a rigorous bulletproof system contract? Or are you just asking an API for text and hoping for the best? Build it right, and your AI integration will be seamless. Thanks so much for joining me on this explainer, and I'll catch you on the next.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.